Can you crack this complex number twist in trigonometry? This is not your usual trigonometry problem. It tests your understanding of complex numbers, real part extraction, and angle manipulation in one beautiful package. Given that A is equal to set of all theta belong to the closed interval 0, 2 pi, such that 1 plus 10 times of real part of 2 cos theta plus I sin theta by cos theta minus 3I sin theta is equal to 0. We are supposed to find the value of sigma theta square, where theta belong to A. We have four options, that is 27 by 4 pi square, 6 pi square, and 21 by 4 pi square, and 8 pi square. Let us consider the complex number in the set, that is, let us take z is equal to 2 cos theta plus I sin theta by cos theta minus 3I sin theta. Conjugate of the denominator is cos theta plus 3I sin theta. Let us rationalize the denominator by multiplying and dividing by the conjugate of the denominator, that is by cos theta plus 3I sin theta. Now let us simplify numerator and denominator separately, which implies 2 cos theta into cos theta is 2 cos square theta here, plus 2 cos theta into 3I sin theta is 6I cos theta sin theta. Next, plus I sin theta into cos theta is I sin theta cos theta here. And finally, we have I sin theta into 3I sin theta, which is 3I square sin square theta. I square is minus 1, so we have minus 3 sin square theta. In the denominator, we have cos theta minus 3I sin theta into cos theta plus 3I sin theta. This is in the form of a minus b into a plus b, which is nothing but a square minus b square. That is, we have cos square theta minus 3 square I square sin square theta. 3 square is 9 sin square theta and I square is minus 1. So we have a square minus b square. We have minus sign in the formula. So we have plus 9 sin square theta. Now let us group the real part and the imaginary part separately. That is, we have 2 cos square theta minus 3 sin square theta is the real part here. And let us add this 6I cos theta plus 6I cos theta sin theta plus I cos theta sin theta, which is 7 cos theta sin theta into I. And denominator is cos square theta plus 9 sin square theta as it is. Now let us consider the real part of this complex number, which is 2 cos square theta minus 3 sin square theta divided by cos square theta plus 9 sin square theta. This is the real part, and imaginary part is I into 7 cos theta plus into sin theta by cos square theta plus 9 sin square theta, which is not required here. We require only real part of z. That is why we are taking 2 cos square theta minus 3 sin square theta divided by cos square theta plus 9 sin square theta. Given that 1 plus 10 times of real part of the complex number is 0 in the problem. So let us substitute for this real part. Real part is 2 cos square theta minus 3 sin square theta by cos square theta plus 9 sin square theta. Therefore, the given expression, that is 1 plus 10 times of real part of 2 cos theta plus I sin theta by cos theta minus 3 I sin theta is equal to 0 becomes 1 plus 20 cos square theta minus 30 sin square theta by cos square theta plus 9 square theta. Let me explain again. We have 1 plus 10 times of real part of this complex number is equal to 0. Real part of this complex number is 2 cos square theta minus 3 sin square theta by cos square theta plus 9 sin square theta. 10 times of this means 10 into 2, that is 20 cos square theta minus 3 into 10, that is 30 sin square theta, and the denominator cos²θ plus 9 sin²θ is as it is. Now let us take the LCM, which is cos²θ plus 9 sin²θ for simplification. So we get cos²θ plus 9 sin²θ plus 20 cos²θ minus 30 sin²θ divided by cos²θ plus 9 sin²θ is equal to 0. So which implies that 21 cos²θ minus 21 sin²θ divided by cos²θ plus 9 sin²θ is equal to 0. That is 20 cos²θ plus 1 cos²θ here. So 20 plus 1, 21 cos²θ, 9 sin²θ minus 13 sin²θ is minus 21 sin²θ divided by cos²θ plus 9 sin²θ is equal to 0. We know that this fraction will be 0 if the numerator is 0. That is 21 cos²θ minus 21 sin²θ must be equal to 0. But 21 into cos²θ minus sin²θ equals 0 implies cos²θ minus sin²θ is equal to 0. That implies cos²θ equals sin²θ. So when you divide by cos²θ, we get tan²θ is equal to 1, which implies that tan theta is equal to plus or minus 1. Now let us find the values of theta. If tan theta equals plus or minus 1 and it is given that theta belongs to 0 to 2 pi, that is first quadrant to fourth quadrant, 0 to 360. So what are the values of theta in 0 to 2 pi, which gives us plus or minus 1 is, first one is tan pi by 4 is 1, and next is 3 pi by 4, and next value is 5 pi by 4, and finally we have 7 pi by 4, which gives us plus or minus 1. That is tan pi by 4 is 1, tan 3 pi by 4 is minus 1, tan 5 pi by 4 is plus 1, and tan 7 pi by 4 is minus 1 in the fourth quadrant. Now the required value is sigma theta square such that theta belongs to A. That is, we have to square all these values and we have to find the sum of that. So we have sigma theta square is equal to pi by 4 whole square, which is pi square by 16, plus 3 pi by 4 whole square, which is 9 pi square by 16, plus 5 pi by 4 whole square is 25 pi square by 16, plus 7 pi by 4 whole square is 49 pi square by 16. So upon simplification, we get 84 pi square by 16. That is 49 plus 150, 50 plus 25, 75, 75 plus 9 is 84 pi square divided by 16. So finally, upon simplification, we will get 21 pi square by 4, which is the required answer. So option C is the correct choice for this problem. Thanks for watching. Don't forget to like, comment and subscribe. Watch the next video. More PYQs are on the way. Let us crack JEE together with Srividya Academy.